Hi, I'm Miss Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. This is in section 9.2. And it's objective 2, identify and classify triangles and quadrilaterals. And in that objective, we have a couple of problems again where we have to solve equations. Okay, so I'm going to go down and focus specifically on the types of angles that form when you have a triangle. Basically, you're going to have two types of diagrams that involve triangles. One is just a triangle, and then the other one is a triangle with a line coming off the side of it. Of course, it's also possible to have diagrams where they have several lines intersecting and a triangle is formed. But within that diagram, you have these. So the significance of the first one on the left is that we know something about the relationship between the angles that are on the inside of the triangle. We call those the interior angles of the triangle. Okay, what do you know about the relationship between those angles? They add up to 180. That's right. Now, the triangle I drew, someone has observed that it looks like it could possibly be equilateral or isosceles, and that's true. But that's not my intention right now. I'm just going for a generic triangle, regardless of whether it's equilateral or not. We know that the sum of the interior angles of a triangle are going to add up to 180. Now, the second diagram is significant because we have extended one side of the triangle to form what's called an exterior angle of the triangle. So in addition to angle A, angle B, and angle C, which we know add up to 180, we also have this other angle here, D. And there are a couple of relationships that we can observe between angle D and the other angles, right? So we already know angle A and angle B and angle C add up to 180. That might help you if you have a diagram like this, depending on what you're looking for. But we also know that angle C plus angle D adds up to what? 180 as well. I'm actually going to write that in reverse just to make a point here. Angle D plus angle C also adds up to 180. And then there's a less obvious relationship. I'm going to write down, this is called the exterior angle. What do you think is the relationship between angles A and B and D? Can you see a relationship between angles A and B and D? A and B have to add up to D. That's right. Very good. Why? Well, if the sum A plus B added to C adds up to 180, and the angle D plus C adds up to 180, it must mean that they were the same, right? A plus B has to equal angle D. That is in our textbook presented as a fact that the sum of the two, what we call alternate interior angles, no, not alternate, sorry, opposite, I misspoke. Opposite interior angles. What are they opposite? They're opposite from where angle D meets the diagram. Opposite interior angles. The sum of the two opposite interior angles, A plus B, is equal to the exterior angle. Oh, I wrote it wrong. Man, I'm full of errors today. Got to be more mindful. Here we go. Equal to the exterior angle D. Okay, so we're going to practice using this to set up and solve equations, these two facts. And as we do that, it's possible some of the other relationships will occur as well. All right, so here we go. Let's start with this one, number 7. Which is what we're going to do in the next video. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.